Hello students, welcome to Short of Sir classes. So this question is from ISI M.Stat paper of 2022. So this is question number 13, which is saying that a 6-digit number is chosen at random. Then what is the probability that at least two consecutive digits in the chosen number are equal? So we have to find at least two consecutive digits are equal, right? So in our case, when okay, so this is the when two consecutive numbers are same, so we can write that we can choose a 6-digit number in how many ways? It will be the first place 9 into remaining of the place will be out of the 10 digits, right? So we will have this 9 into 10 to the power 5. For this is the case when two consecutive numbers are same. Now when two consecutive numbers are not same, then we can choose this 6-digit number in 9 to the power 6 ways, right? And it is 9 to the power 9 into 10 to the power 5 ways. Now probability of choosing a number, okay, so we can find the probability of choosing a number which has no two consecutive numbers, no two consecutive digits are same. So it is pretty simple that here we have 9 to the power 6 ways. From here we find, so it will be divided by the when the two consecutive numbers are same, so it will be 9 to the power 6 divided by 9 to the power 9 into 10 to the power 5, so which is simply 0.9 to the power 5. Now we have to find that the probability of choosing the number with at least two consecutive numbers same, consecutive digits equal or same, it will have just 1 minus 0.9 to the power 5. So this is our correct answer. So for question number 13, we have the correct option as A, that is 1 minus 0.9 to the power 5. Question number 14 is saying that a multiple choice test question consists of 20 questions. This multiple choice test means MCQ. We have this 20 question with have, and each question has 4 choices, exactly one of which is correct. So for each question, a student is able to correctly identify one of the choices as wrong and chooses one answer at random from the remaining 3 choices. The student will get a scholarship if she answers at least 18 questions correctly, right? So we have to find what is the probability that the student will get the scholarship. So what is the she can this the student so she can answer one question. Okay, she can answer one question in 3 ways, right? Because we have that chooses one answer at random from the following 3 choices. So she can answer one question in 3 ways. So exactly we have to get a scholarship, we have to get exactly at least 18 questions correctly. So she can answer exactly 18 questions correctly with probability that it will be just, so he can choose the random, it will be chooses one answer at random from the remaining 3 choices. So it will be out of 18 questions to be precisely correct. So 1 by 3 to the power 18 and the remaining to the power 3 by, okay. So she can answer the this exactly 19 questions. If we find to exactly 19 questions correctly, so in that case it will be simply 1 by 3 to the power 19 multiplied by 2 by 3 and exactly 20 questions. That means all the 20 questions correctly. So that will be equal to this 1 by 3 to the power 20. Okay. So the probability that she will get the scholarship, so we have to find that the probability that she will get the scholarship. Okay, so it will be simply, so out of 20 questions, so correct will be 18. So 20 multiplied by this factor of 1 by 3 to the power 18, right, into multiplied by 2 by 3 to the square. So it will be 4 by 3 to the power 20 plus, so 19 questions out of 20, we will have this only into multiplied by 2 by 3 to the power 20 plus, it is simply 1 by 3 to the power 20, right? Now if we do the calculation, so it is pretty simple. So we have 20 factorial by 18 factorial into 4 by 3 to the power 20 plus 20 factorial by 19 factorial into 2 by 3 to the power 20 plus 1 by 3 to the power 20, right? So 20 and 19, it will just cancel out. So it will have this 18 factorial means 20, we can write in this manner. This, it will be just simply 20 into 19 and the remaining will cancel out. So here we have 2 factorial is remaining. Okay, so okay, so we have this also 1 factorial is there, so not writing this, so it will be 1 factorial and it is 2 factorial. So we can simply cancel out this 2 10. Okay, so it will be 19 into 10 into 4 and it is 20 factorial. So we will have this only 20, 19 factorial we cancel out. So we have 10 into 19 into 4 plus 20 into 2 plus 1 by 3 to the power 20. So here we'll have this, if we do the plus, so it will be 760 plus 40 plus 1, so it will be 801 by 3 to the power 20. So this is our correct option, which is the correct answer. The option in this case is this option D is the correct one. 801 by 2 to the power 20. Question number 15, it is saying that the probability that a lie detector correctly determines whether a person is lying or telling the truth is 0.8, independently of whether the person is actually lying. Assume that the people tell the truth 95% of the times. Given that for a particular person, that lie detector says that the person is telling the truth, so we have to find the conditional probability that he is actually telling the truth. So let us consider L, which is the lie detector that tests truth, and we have this P of E, that is person who is telling the truth. Okay, so I have to find simple that the conditional probability that he is actually telling the truth. So we have this probability of PE provided L has occurred. So we can simplify this as probability of PE intersection of L by probability of L, right? So this we can simplify as the PE intersection of L as, so we have this probability of L by L conditional probability of PE, that is the person, whether the person is telling the truth, telling or lying, telling the truth or lying, and that is been determined by the lie detector, multiplied by probability of the person who is telling the truth divided by the, as it is we have the probability of the lie detector detecting the truth. So here this value is given as that the probability or that a lie detector correctly determines whether the person is lying or telling the truth is 0.8. So this is given as 0.8. Okay, and the probability of person is telling the truth, most of the times it is 95%. Okay, given over here, so it is 0.95, and the probability of L is 0.95, so the conditional probability is simply 0.8. So the correct option in our case is that is the probability that the person is actually telling the truth, it is 0.8, option C.